Hi, good afternoon, everybody. We are going to start in about 5 minutes. Get your snacks, get your water, get your books, and we're going to jump straight into vectors and matrices. Take this opportunity to just do a quick recap of whatever notes you have so that you are refreshed with the content. So when we get started, you're good to go. So 5 minutes and we're going to begin. Please confirm that you guys can see and you guys can hear so that I know we're good to go. All right, guys, let's jump straight into it. Before we get started, one of the things I want to kind of remind you guys of is that the awesome thing about vectors and matrices is most of the questions, the format of the question is repetitive. So to be honest, if we go through minimum 4 to 5 past papers, there should be some things that you will learn and understand and should be able to be more comfortable with the questions. So if you guys are ready, just type ready and we're going to get started. Okay, I see the readies coming through. All right. Okay, so let's look at the first question. Now, two things you need to keep in mind is that vectors and matrices, you can get questions in relations to um, actual formulas, or you could get the information from a graph. And that's why I tend to try to sketch even when we're just dealing with the formulas. So the first question, they gave us some points on a graph. Before we even get to that, would everybody be able to identify each point? So I'm going to start off with R. What is the coordinates of R? Keep it in mind, what does coordinates mean? The X location and the Y location. So what would be the coordinates of R? If we look on the X axis, the value of X is 5. And everybody seeing where R is? This is where R is right here. So just to make sure you're looking at the right position. So point R is located at X is 5 and Y is 1. Everybody see that? So even before we do anything, we identifying these positions. Let's look for P. Where is P? What is the coordinates of P? The coordinates of P has an X value of -2 and a Y value, we go up to +4. Okay, so I'm seeing persons sending it to me directly through the chat. Either way works for me. So let's try to make sure we all participate. So now that we know we could identify and we know the origin is O. Anybody remember the coordinates of the origin? The coordinates of the origin is where X is 0, right in the middle here, and Y is also 0. This is something standard. This is something you must always remember. All right, so let's go into the first question. Write the position vector of R or R in the form AB. No, we know that the position vector means that it is generated from the origin. And so we just use the point R to get this answer here. So what is the point R? 5, 1. But instead of having it horizontal, which form they ask you for? The vertical form. And what we should remember is who always comes first. X always comes first and Y always comes second. So therefore, we just change this format to this format. So the answer is simply just 5, 1. Everybody with me? So anytime they ask you for a position vector, what do you use? You just use the point of, or the coordinates of that point to represent it as this vector here. Everybody good to go? I get 1 yes so far. And keep in mind, this is a question that could be repeated over and over. So if you didn't know it before, you should have an idea now. All right, just for the point of practice, what would be P in the form of a vector AB? So I want P in this form here as well. And keep in mind, the position vector is called OP because it comes from the origin and goes to P. We just simply take this point and rewrite it vertically. So it would become -2 to the top and 4 to the bottom. And that's literally it. That's how you change a coordinate to a position vector. All right, so let's keep moving now. Next question. So we see we have that part. Another point Q is located in such a way that QR is 2, -4. Using this information, plot the point Q on the graph. Now question, do I just plot this point here, 2, -4? Yes or no? Would these two things be the same thing? Excellent observation. The only time that we could use it is when it represents what? If it was OQ, then we could do that, but it's not OQ. This vector represents a movement from where to where. Where's the start point? From Q to R. Everybody understand now? No, this vector describes what is happening with that movement. This is your X movement and this is your Y movement. So first question is, when X is positive, what direction we usually go to? We're going 2 to the right, 2 places to the right. Everybody see that? Because it's a positive X. When Y is negative, does that represent going up or going down? Excellent. So that means, this means 4 going down. Everybody following me so far? So let's see how we go about getting this information done. What they did, they took 2 approaches. They took the formula approach, which is what we're going to look at, and then they applied it to the diagram. So let's go back. Let's look at the information that we have, and we should remember the triangular rule. If I want QR, what do I need to get QR? Which 2 information we have? We have OR already. So what formula can I use to get to QR? Wouldn't that be OQ plus, sorry, not OQ. Let me change it. We were just looking at it just now, sorry. Let's go back up here. QO and not OQ. All right, so everybody seen the formula? So this is what we would have practiced a lot, the triangular rule or the triangular law. And what information did we get? We had this from before because they gave us this. Everybody realize that? What other information did we have from before? We also had this information from before. So how do I go about getting this? all we simply do is just use algebra. But before we continue, let me know if I need to explain from the basics, how do we get here? Do y'all need me to break it down? Talk fast. Okay, I have a few persons saying yes. Some people saying no. So let me just explain it just in case. Just in case. Okay, let's say we want some ideas of how to build a vector from scratch. Let's say we have a OR. Let's say we have a OP. And let's say I want you to form RP. How do we get from R to P? If I want to get from R to P, I need to use the triangular law to build the path to move from R to P. But I don't have a path that starts at R. But guess what I do have? I have a path that goes from O to R. So what can I do? I could switch this around. And instead of OR, I could write what? RO. Everybody following me so far? Plus OP. And what does this mean? You start off at point R, you move to point O. And remember, O is the same position. So it's almost like you're doing two things at once. Once you reach O, you could then go from O straight over to P. That is what we call the triangular law. And just to draw, to make sure you understand, let's say this is my R, let's say this is my P. So this is just a quick revision so we could understand, right? So let's go. What does OR mean? OR means you start from the origin to R. What does OP mean? From the origin to P. Keeping in mind though, these lines have directions. So OR gonna go from O to R. OP is going from O to P. But let's look at it. If I want to travel along these paths to get from R to P, where do I have to go first? I must go from R to O and then from O to P. You seeing it now? That is the only way I can actually get from R straight to P. And that's why you call it the triangular law. To get a direct connection between R and P, I have to go back to the origin and then go from the origin to P. And when you look at that pathway, it creates the triangle. So that is what we did here. We were given OR, we were given OP, but we went the opposite direction of OR, which is RO, and then we went from RO to OP. So that is what is happening over here. So I hope you understand the connection now. And all they did now was substitute the values. So you see here, we know that 2 is equal to some negative x plus 5. And that is why they broke it down here. And they solve for the x value. So we know that x value must be 3. Same thing they did with the y value. Y plus 1 or negative y plus 1 must give us negative 4, sorry. What value is that? That value must be 5. And so the point, or OQ, is the same thing as finding coordinate Q, and that is what you use to plot. Everybody talk to me. Out of 10, because remember, this is what we just recently learned in our previous classes. So it's just the application of it. How you feeling about what we just did now? And all you had to do was plot that point and you're good to go. So we're going to continue with some more examples. Let's keep it moving. Determine the magnitude of QR. Now I want to make this very clear. You realize in vectors, these two lines mean magnitude. Anybody remember what these two lines mean in matrices? Because in matrices, these two lines mean something else. So if I was to give you this in matrices, what does this mean? These two lines mean the determinant in the topic matrices, but in vectors, it means the size or it means the length So you realize these two lines mean something completely different. Students just confuse them all the time. So please remember, when you're dealing with vectors and you see these two lines, it means the magnitude. Magnitude means size. In matrices, this means the determinant. And the determinant have a formula, AD minus BC. So quick revision, quick clarification. All right, so let's go. If you remember, what is the formula to find the magnitude of any vector? It's almost like the Pythagoras theorem. The square root of x squared plus y squared. Okay, if you don't know this or you didn't know it before, please write it down. And so all we need to do is write down what is the point QR, and they gave it to us before. Where is it? Look at here. QR is 2, -4. So that means x is +2, y is -4. Everybody following me so far? So all you need to do is substitute. So you put the square root of 2 squared plus -4 squared. Let's do it together. So we're going to end up with 4 plus 16, which is equal to the square root of 20. You put this in your calculator, you write your answer. And you're going to write units. Why units? When you measure how long something is, you'd just say 3, or you would identify if it's centimeters, meters, kilometers. So that's why it's important to make sure you state units. But this is pretty simple. This is for everybody for the purpose of practice. I'm going to give you a vector. Let's say there's a vector MP. And MP has 2, let me see. Let me say 4, 5, 4, 3, 4, 3, 4. What is the magnitude of this vector? Everybody right now, I need to see the answers flowing in. Because once you guys get this right, anytime it comes back up, you should be good to go. And this is an easy one to calculate. You don't even need a calculator. Keeping in mind, we should remember the formula. The formula is the square root of x squared plus y squared. We should also remember the number at the top is what we would call our x value. The number at the bottom is our y value. So what is my answer? So I have one answer so far. Anybody else? Excellent job, everybody. Excellent job, because this is a simple case of substitution. So this would become 3 squared plus 4 squared, which is the square root of 9 plus 16. Then we know 9 plus 16 is 25, and we know the square root of 25 is 5 units. Okay, we must be able to manipulate these things. Okay, so everybody good with the size or the magnitude of a vector? Oh, see, you have to be careful of what you're adding. Okay, straight to the point. Now, this question is the harder version of the vector question. It's not hard if it only would be hard if you don't know what you're doing. It says show by calculation that OPQR is a parallelogram. First of all, do everybody know what a parallelogram is? A parallelogram is a 4-sided figure that has 2 sets of parallel sides. So let me just put the arrows so we could make sure we clear. Okay, my thing don't look very parallel, but you know what I'm trying to do. So we have this side is parallel, this side is parallel, this side is parallel, this side is parallel to each other. And if you remember the law, how do we know if 2 sides are parallel? in vectors? Anybody remember? So let's say, for example, I have a vector PM, and vector PM is 3, 5. And I have a vector QR, and the vector QR is 6, 10. So everybody, is it a parallel case here with these two vectors? Because we got to remember what makes two vectors parallel. So Myrtle says yes. So that means, do everybody else forgot? Yes, they are. How do we know? These two are related to each other. One is a multiple of the other. What number can I multiply to 3 to get 6? If I take that same number and I multiply it by 5, do I get 10? So let's check it out. And this is an obvious one, because remember, there are some that are not obvious. So the truth is, how do you find K? K, you must say QR divided by PM. And when you divide those two, if you get one constant number, that's your K. So look at it. 6 divided by 3 is equal to what? 2. 10 divided by 5 is equal to what? 2. So that means in this example, K is equal to 2. Everybody see that? So sometimes don't forget, don't ever trust it. Remember, you have examples where you could have a multiple that is a decimal. So maybe K could be 1.5. It's not as easy to see if K is 1.5. So always back check and divide this number by this number, and your answer should be the same when you divide this number by this number. Everybody with me? So let's get to the point now. If you could identify that two lines are parallel, you could determine if something is a parallelogram. Why? Because you're looking for two sets of parallel lines. So after you check these two parallel, you got to check if these two parallel. Once you could prove that all of them are parallel, you know it's a parallelogram. So everybody understand what we should be looking for now? Talk to me, talk to me. You must be looking for some information to prove that all sides or opposite sides are parallel. So what we're going to do, we're going to just use the notes here to prove it, rather than going through all kind of drama. Here, what approach did they use with this graph? You realize they drew it. So they had, remember, we plotted all points from before. So all they did was connect the sides, but that's not good enough. You can't just connect the sides and leave it like that. So you have to label your vectors. What's the first vector here? P and O. That means what we want to try to do first is prove that PO is parallel to who? QR. Everybody with me? So let's take a look and see what's happening here. Here we know OP was this. This is what they gave us, but what are we looking for? We're not looking for OP. We're looking for PO. And everybody remember, if going in one direction, this is A. Going in the opposite direction is what, guys? With vectors. If going to the right is positive A, what is happening when you're going to the left? Negative A. That's a basic concept we must know. So if our given vector OP was 2, -4, PO is the opposite direction. So I hope you realize they put a negative outside here, and they're going to multiply each term by the negative. So let's look at that. Let me zoom in a bit. What we should realize here is what? A negative and a negative is going to give us what? A positive. And a negative and a positive is going to give us a negative. So this is our PO vector. Who do we need to find now? We need to find QR. Remember, we didn't calculate that already. You see, it says here it was given. What do y'all realize here with OP and with PO and QR? Do we have to calculate anything? What is K in this example? Let me see who's thinking. There is a K, but what is K in this example? Even though they're the exact same thing. What number do you multiply by something to get back the same thing? Excellent. So in this example, K is 1. Excellent. Don't ever be fooled. You must find K. Anytime you're showing two lines are parallel, you must say K is equal to 1. All right. So it says here, if one pair of opposite sides of the quadrilateral are both parallel and equal, then the quadrilateral is a parallelogram. So what you realize they did here, they proved that these two sides, opposite sides, are parallel. I guess they took the shortcut and they didn't prove these two were parallel. But I would recommend look at the max. If the max is like 4 or 5, prove that both of them are parallel. Everybody with me? And another thing that's even more important, what you realize going on here, there's a statement. They ain't just do the calculation and leave it. You must state that if both lines are both parallel and equal, then the quadrilateral is a parallelogram. Everybody with me? Now, this is just some notes. I actually need you guys to take a picture of this and write this out. These is just general information that you need to know. There are other conditions that are sufficient to prove that the quadrilateral is a parallelogram. That means that's just one way that they chose above. There are different ways to show that it's a parallelogram. So look at the first way. Both pairs of opposite sides are equal to each other. Anytime the lengths of those two sides are equal, it's automatically a parallelogram. Both pairs of opposite sides are parallel to each other. That's the way I just explained to you guys. That would have been the easier way. You take the two sides, you prove that they're parallel by looking for K, and that's the answer. Similarly, there's another way. Both pairs of opposite angles, but guys, do not do this one. Oh no, don't do this one. Because like we don't have enough time to teach this. So I would not recommend this one. Anything with the angles. So the second two. Similarly, the last one, no, we ain't got no time for that either. So I say stick to the first two. If you have time and energy and you want to go and research these other 3, I recommend you do so, but it's not necessary. Okay? So let's move on now to matrices, because that's it for vectors. So in all honesty, before we move on to the matrices part, how everybody feel about this first part with the vectors? You realize it, nothing was beyond your ability. Once you know the rules, it's pretty simple. And I don't know why students just panic with vectors and matrices, because once you remember the basic stuff, it's pretty easy to handle. All right, so let's jump into the matrices part. So it says here, calculate the value of X and the value of Y in the matrix equation below. So my first question to everybody is, let's call this matrix A, let's call this matrix B. What is happening between two of them? And this is the answer. The answer is C. What operation is happening between A and B? You realize there's no operation, but they're next to each other. What operation happens when you're next to each other like this? Excellent, multiplying. Anytime two matrices are up next to each other like this, the operation is multiplying. Second question, what is the order of the first matrix? Okay, very good. Anybody else? I've seen some people. When I say order, what does that mean? The number of rows times the number of columns. So if I see here, I know it's 2 rows. So that means it's a 2. How much columns? 2 columns, 2 by 2. Similarly, what is the order of B? Excellent. So just for curiosity purposes, can these two matrices be multiplied? So I'm just going to take some time to make sure I just cover these basic stuff. If I have a 2 by 2 matrix and I multiply it by a 2 by 2 matrix, how do I know they can be multiplied? What's the rule we're looking for? What must match? These two inner numbers must match. What does these two inner numbers represent? The column of the first matrix must be equal to the row of the second matrix. Don't ever get this confused, because they asked this question in paper 1. Everybody with me? The column of the first matrix must be the same as the number of rows in the second matrix, aka the two center numbers. Once they match, you're good to go with multiplying. Okay, similarly, I would like to know what is the order of the answer. When you multiply this, you're going to get a matrix, right? What is the order of that matrix you're going to get? How do you find out that information? You see these two numbers on the end? The numbers on the end tell you the answer, the order of the answer. So that means your answer is going to be a 2 by 2 matrix. Everybody with me? Because these are things we need to know before we move any further. Okay. Seeing people saying they got it. So let's get into the question now. Now you look at this, you know, first thing first, these two can be multiplied. And so you realize we're going to have to do with some algebra. Anytime you realize you have a value X and Y and you need to figure out what those values are, you know, you got some algebra to do. So what would you do to figure that out? Let's do it together. We will multiply it out based on what we know what to do, right? So let's break it down. I know we need to multiply what rows by columns. So I would always do what? Circle my rows in the first matrix and circle what? My columns in the second matrix. Because what's the rule? Row times column. Second thing to do is to map out your answer. How is your answer mapped out? You know your answer is what? A 2 by 2, right? So you map out your spaces, a 2 by 2. So let's go now. Follow me, work with me. Let's go. So we know we have a top and a bottom, a left and a right. So we're going to try to find the answer for the top left. So guess which two we're going to use? We're going to use the top row and the left column. So that means 1 times -4 plus what? 5 times 2. Everybody agree with that? Basic stuff we need to remember. Excellent. Let's do the top right now. So we're using the top numbers and the right numbers. So that would be what? 1 times 1. Seen it? 1 times 1 plus 5 times 9. Everybody following so far? Let me know before I continue. Because remember, you're trying to find the value of each position. These are the rules for multiplying matrices. So far, I see 1 yes. I see following. You feel lost. Okay. So that means I would have to send you these sessions with multiplying matrices because we did a few practices with this only. So I'm going to try to get that to you. Okay. So there we go. Now we want to get the value for the bottom left position. This is the bottom left position. So let's see if you could pick up on what we're doing, even if you're not sure or confident. So let's go. Look at the bottom numbers. What are the bottom numbers? 2 and Y. What are the left values? -4 and 2. So you multiply the first 2 in each, add it to the product of the second 2. So what's the first 2 numbers? The first 2 numbers is 2 times -4. You see that? Now let's look at the 2 numbers, the second numbers in the same row and the same column, which would be what? So you put your plus, so it will be Y times 2. Y times 2. All right, let's do the next one. Bottom right. What are the values for bottom right? 2 times 1 plus Y times 9. Now, let's zoom in here. When you reach this phase, you go no further until you do what? You back check. What am I back checking for? The pattern. So look at the pattern. -4 should match with -4. Times 2 should match with times 2. Times 1 should match with times 1. Times 9 should match with times 9. Everybody see that? That's how you back check. Okay, so let's work it out now. Let's keep going. Let's keep going. What is the answer for the first one? Can we go straight to it, or let me do it the long ways? 1 times -4 is -4 plus 5 times 2 is 10. Let's do the one to the bottom. 2 times -4 is -8 plus y times 2 is 2y. 1 times 1 is 1 plus 5 times 9 is 45. 2 times 1 is 2 plus 9 times y is 9y. So let's take a pause here. Everybody okay? We keep going. If you realize multiplying matrices is a weakness, that's an easy fix, pretty easy fix. So let's go. -4 plus 10. Well, we should remember the signs are different. You subtract the two values. Your answer, take the sign of the bigger number. No. Stick it out. Don't leave, because then you can just put yourself at a bigger disadvantage, okay? So just try to follow so long. So this is going to be +6. This is going to be 46. This is going to be what? Can I add these two values here? No, I cannot. You cannot add a constant to a variable. Remember, the 2y is a variable, so you have to put back the same thing. Everybody see that? Same thing here, 2 plus 9y. So once you get this, where do you go from here? Remember, they gave you the answer for that. When you multiply these two things, they gave you the answer over here. So guess what you have to do? Match it up. So this is equal to x 46, 6 65. Anybody know what you're supposed to do with this information? What is the value for x? Let me see who's thinking. What is the value of x? The answer is a direct answer. If I tell you this matrix is equal to this matrix, what does that mean? The matrices that hold the same position are equal. So that means this is equal to this. So that means x is just equal to 6. Everybody see that? So how can I use this concept to find y? So basically, I know that what? This is equal to what? All of this is equal to what? So let me write it out. -8 plus 2y, all of that is going to be equal to that. So what do we do here? We transpose to find the value of y. So who do we get rid of first? And you realize every time we do this, I ask the same questions because this is something we make mistakes with a lot. Who do we move first? Excellent. We got to move the 8 first. When we move it, what does it become? It changes from -8 to what? Excellent. So we're going to end up with 2y is equal to 6 plus 8. So that means 2y is equal to what? 14. What is the answer then? Excellent. Excellent. So y is equal to 7. Excellent. So you see here how algebra, you see matrix is mostly algebra with some specific rules. So once you know how to do that, you're good to go. So we now know x is equal to 6, y is equal to 7, and that's it. That's it. That's it. That's it. That's it. Here we go. We got the answer. No, I'm gonna be honest with you. This part of the question we can't do right now because this requires a lot of teaching and we can't accommodate transformations at this moment. So for now, we're gonna skip this and we're gonna come back to it during some revision before exams. I want to cover everything we need to cover first because the truth is, if you don't answer a question, this part of the question, it won't stop you from getting a 1. It won't stop you from passing. but it's just that this is a complex concept that we can't accommodate at this moment. So we can just move on for now. So where are we moving on to the next exam? We just finished January 2022, which was our exam that just went recently. Now we're moving on to January 2021. How was the matrix question? Do you feel like it was beyond your understanding? Even if you didn't remember anything, how you feel about that question so far? You realize all we had to do was multiply and substitute and solve. So it wasn't too out of reach. No, 2021, they actually put matrix first and vectors second. It doesn't matter, you handle it, both of it accordingly. So let's see what this question asks us for. So there we go. Just a couple blanks. Okay, no problem. And we could fix those blanks easily. All right, so given matrix W, so we have a matrix W, 3, 6, negative 2, 5. Something you need to realize, it's a 2 by 2 matrix. All right, so it says here, determine the 2 by 2 matrix L such that W plus L is equal to 0. So that means when I add something, I gotta add something to W to give me all 0 values for every position. You could use 2 concepts here, guys. Anybody remember inverses, addition inverses? What does that mean? If I have positive 3, what is the opposite of positive 3 that would give me 0? Isn't it minus 3? This is what we call additive inverses. Because you know you got different types of inverses. You got a multiplication inverses. So if I had negative 5, what is the opposite of negative 5 that would give me 0? Plus 5. Everybody with me? So I am going to teach you based on this because there's 2 ways. There's using this concept and then there's the algebra way. The algebra way is to do this. Say W plus L is equal to, we're going to call this the identity matrix for addition. How do we find L? What did we learn about doing that? We subtract, right? If I want to get L by itself, I would subtract W. What you do on one side, you do on the opposite side. Everybody following me so far? Same thing with transposing. So L would be equal to I minus W. And I is just where all of the elements are 0. So we just subtract and then we would have gotten L. But I ain't going through all of that. We don't have no time to waste. So let's see if we thinking. Let's see if we could look at this and come up with L without the calculating element. What can I do to 3 to get 0? What element do I apply to 3 to get 0? What do I add to 3? What do I subtract from 3 to get 0? So there we go. I see a negative, excellent. So our first element would be negative 3. What would be the element that corresponds with positive 6? Negative 6 was the value that would correspond to negative 2. Excellent. Similarly, what value corresponds to positive 5? Excellent. Let's go down and see. You realize all this work? Look at what it did. Substitute the same thing I taught you with the whole thing to get the same thing that we got right here. Everybody see the point of working smart and hard? Why go through all of this when you could just say, and you know you just use a sentence and say, applying the inverse concept, you get the same answer. Where did it go? Everybody following what I'm trying to show you about the difference between working smart and working hard? Ain't the same answer we got. And how long did it take us to do that? Literally 5 seconds. Maybe 15, maybe 15. Why go through all of this? So you could get your marks easily, all you needed to say. And that's what I want y'all to be aware of. If you know you have a smart way of working out something and you know it's going to work, you just write a sentence explaining what method you're using. So I would say applying additive inverse, because you have to make sure you say it's additive inverse, because there's additive inverse and multiplication inverse. For example, just to make sure we understand, what's the multiplication inverse of positive 3? 1 over 3. Or we could write it as 3 minus 1. Everybody following? So we have the additive inverse, so 3 and negative 3, these are inverses on the addition. And then we have the inverse on the multiplication, which would be these two over here. All right, so let's keep it moving. That was an easy one. Question number 2. The 2 by 2, so we need to determine the 2 by 2 matrix such that WP is equal to the identity from multiplication. Remember, Talar, you need to learn this type of matrix. Anytime you see this matrix, it's called the identity matrix for multiplication. And I'm going to tell you what this means. This means that anytime you multiply this to any matrix, you're going to get back the same matrix. So if I take W and I multiply by I, which is this, I'm going to get back the same thing, W. Okay? So let's take a look and see how they went about doing this. So they say determine P such that WP is equal to that. We learned this before. So let's go. I'm going to go to the side rather than doing all of this. So we know they said WP is equal to what? 1, 0, 0, 1. Which one did they give us? They gave us W. So let's substitute that. What was W? W, look at here, 3, 6, negative 2, 5. 3, 6, negative 2, 5 times some other matrix. We're going to use some letters to represent that. Let's use A, B, C, D. So WP is equal to this. How do we find P again, guys? Y'all remember this? If we want to get rid of W, what do we do to get rid of W? We multiply it by the inverse of W, right or wrong? Whatever you do on one side, you do to the other side. So this and this will cancel. This is literally what we did the last time. So we know A, B, C, D is equal to 1, 0, 0, 1 times the inverse of W. Let's ask this quick question. Do we have the inverse of W at this moment? Let me ask a question. Do we have the inverse of W at the moment? Or we only have W? We don't have the inverse. So guess what we got to do? We got to calculate the inverse. We got to calculate the inverse. So let's go. How do we calculate inverse? There's a formula. Anybody remember the formula? Is the adjoint of W times, let me put it back, is 1 over the determinant of W times the adjoint of W. In all honesty, how much people remember this formula? You need to memorize this. I'm waiting for a few more persons, okay? I'm seeing people saying they did. You remembered, okay? So let we go. You didn't, okay? That's the purpose of this. This is a very huge component of matrices. You must remember the formula for inverse. You must remember the formula for inverse. So if you didn't remember it before, stick it in your brain now. So let's go through it together. So let's take it step by step. To calculate the inverse, you need two things. What are those two things? You need the determinant and you need the adjoint. So let's find the determinant first. And you realize the determinant can be represented in any way. You could say this or you could say that. Same thing. It has a formula. What's the formula? AD minus BC. So let me ask this quick question. Look W here. Which one is A? Which one is D? Which two numbers I should be multiplying by? Let's go. Okay, Myrta said 3 and 5. Okay, 3 times 5. Excellent. Very good. Minus BC. What is BC? Six times negative 2. Everybody give me this answer here, and I'm not moving on until I see at least 5 to 6 people sending me the answer. Because there's something about questions like this, for some reason, students just make small mistakes and get the wrong value. So everybody tell me what value you get when you work out this. What's your single digit or your single numeral value? What's the answer? And that's specifically why I asked. Come, everybody, let's go, let's go, let's go. Everybody telling me the same thing so far. I see one different answer. And this is specifically why I asked everybody. So guess what, guys? Let's see. 3 times 5 is 15. Minus, because that's separate from this negative 2. 6 times negative 2 is negative 12. You see what happened there? Everybody see the mistake y'all make? Which is why I asked everybody to do it. You cannot afford to make mistakes of this nature. So my priority right now is to ensure that you don't slip up and make these type of mistakes. So you know this is going to become what? 15 plus 12. So this is going to be 27. Everybody with me? That's why I need y'all to practice these things. Okay, good. Now that we have the adjoint, the determinant, which is 27, we need to find the adjoint. How do we find the adjoint of any matrix? It's 2 steps. The first thing you do is you switch the leading diagonal. So 3 and 5 would swap positions. And then you apply -1. You multiply the non-leading elements by -1. So you apply -1 to 6 and you multiply -2 by -1. So what do you think we're going to end up with? What's the first element going to be now? Instead of 3, what is it going to be? Okay, yes, I see some people. Very good. 5. So I'll just switch it one time. Instead of waiting until I come down, I'll just switch it like that one time. So we know the 3 and the 5 switch. And instead of +6, excellent, it's going to become -6. And instead of -2, it's going to become +2. That's it. That's how you find the adjoint. You switch the 2, A and D, and you multiply B and C by -1. So do we have everything we need now for the inverse? Because remember, the inverse is what? 1 over the determinant times the adjoint. So what does that mean? It means this is going to be 1 over 27 times the adjoint, which is what we just found, 5, -6, 2, and 3. How do I apply this to this? How do I apply what is outside to what is inside? Anybody remember? What does this mean? 1 over 27. If I multiply by 1 over 27, it is the same thing as doing what? Dividing by 27. Excellent. So each digit would be divided by 27. So it's going to become 5 over 27, -6 over 27, 2 over 27, 3 over 27. And if there's any one of these here that could be broken down, you break it down. And 2 of them could be broken down because 6 and 3 has a common factor of 3. 6 and 27, sorry. So you could break it down. So let's go over here. And exactly what I said is exactly what happened. So you see, this is what we have. And they broke it down. 3 can go into this 2 times. So you get -2. 3 can go into this 9 times, you get 9. Everybody see that? So it's all about breaking it down after you find it. Similarly, 3 into itself goes once, 3 into 27 goes 9 times. So you break it down to this form. And guess what? That's it. How was that for you? How was that for you? Out of 10, let's go. How you feel so far by what we did? Okay, so this is the last. I'm watching. I'm hoping that you guys are picking up on certain things. You're realizing certain things as well. Okay. Now, this is a small issue. You realize what's going on here now? Watch the topic here again. Transformation. So we can't answer this at this moment, unfortunately. But please don't hesitate. I have notes on it. If you want me to send you the notes so you could probably read up on it on your own, you can until I get a chance to get to it. So yeah, we're going to just skip this whole entire part here. B, I think this part was what, 2-3 marks. So let's go on to vectors. No, let me just let y'all know. This question is probably the hardest type of question that could come for vectors. So if we could get through this question and you understand everything, you should be able to handle any vectors question moving forward. So I need y'all to be mentally prepared. Take a deep breath and we're going to run through it step by step. So just type in the chat. Let me know if you guys are ready and we're going to break it down. And the reason why this is going to be challenging is because it deals with fractions. So you're going to need your calculator. I'm going to teach you how to work these out as fast as you can with your calculators, because if you go and try to add and subtract fractions with these things on your own, you're going to have a high probability of making mistakes, okay? All right, before we get into the actual diagram, everybody understand how vectors work? Based on this image, I would like you to tell me how many vectors do you see? That's the first question. How many vectors do you see? Okay, I've seen some numbers. Let's go, guys. How many vectors do you see? Because if you can't tell me how much vectors you see, we're done in a bad position. So I need to know what you're seeing. How much you seeing? Okay. There are only 3 vectors shown on this diagram. What is used to represent vectors, guys? What's the number 1 rule you need to see for a line to become a vector? No, you need to look for the arrows. How much arrows you're seeing? So look at it. The first vector that I see is from 0 or O to Q. And you have 2 names. You could call it OQ, or what's another name for that same vector? V. Agree or disagree? Because remember, you have different ways of representing vectors. You could use the beginning point and the end point, and you use the arrow to show what direction you're moving. Or you could represent it using a common letter. So V says it's a movement from O to Q. What would be QO? How would I represent QO? Let me see if anybody thinking. If from O to Q is positive V, excellent. From Q to O is negative V. Okay? That's right. All right, so that's one vector. Everybody, what's the name of a second vector? Who could give me the name of another vector? Excellent. U. What are the ending? So we have U and we have 2U. So U is from L to P, and 2U is from O to L. Everybody see that? So you use these vectors to move around. So the truth is you can go from O all the way to R if you wanted to. You could go from O to P, O to M, O to Q, but you have to be careful how you do so. And that's what we're going to be looking at. So let's read the information first of all, because this is the information students get confused by. So let's take a look at it. The diagram below shows a triangle OPQ. Let's look. Every time you read something, look at the diagram. Make sure you understand the connection between the words and the actual diagram. So you see the triangle OPQ, in which OP is 3U. And look at that. You realize this information isn't shown on the actual diagram. What did they say? To go from O to P is 3U. Do you agree? Yes, because if you add 2U plus U, how much you gonna get? Everybody see now? So you must be able to make the connections even before you look at the question itself. So only one person saying that they see the connection. Talk to me, talk to me. Okay, good. Okay, good. All right. So let's keep it moving now. So we see how they get 3Q. It makes sense because, you know, you have to add vectors, right? So if I want to go from O to P, I got to add 2U plus U to get from there to there. So that makes sense. That check out. OQ is V. We already see that. Straightforward. So we agree and we understand this part. Now look at this part now. Q is the midpoint. Where is Q? Q is the midpoint of OR. So you realize this is halfway. So guess what? If this is halfway, because this line has an arrow, this entire line can be represented as a vector. So that means that what would be from Q to R? What can I use to represent this distance here? Let me see if anybody thinking. If Q is the midpoint from O to Q of the entire line, so here to here is V. What is here to here? Isn't it also V? If Q is the middle of the line, if it's half, that means this distance is the same distance as here. So if this distance is V, this distance must be V as well. So the entire line would be what? What would be the entire line? 2V. Everybody following how we got that? You have to pay attention to these words. Midpoint. Remember, midpoint means halfway. So if something is halfway, that means both ends would be equal distances. So if here to here is V, that means here to here is also V. And that means the whole entire line would be V plus V, which is 2V. Basic algebra content. Let me know if you got it or don't got it. Talk fast. Let me know. And to be honest, I'm gonna be honest with you, vectors is like a puzzle, you know, to be honest. It's like a puzzle. So if you like puzzles and you like maps and stuff like that, you should be pretty okay once you understand what to do. So let's continue. So we understand this whole concept of midpoints. And who else is a midpoint? M is a midpoint between P and Q. But you got to be careful because you realize there's no real no vectors really coming here. We do understand it is halfway. So we know this distance is the same distance as here. That's how you could use for now. Now, watch what gets really interesting. L is a point on OP. Where's OP? Here is L. And here's how things get tricky. Watch what they're gonna do. Such that OL, which is this distance here, is 2/3 of OP. So guess what? If this is 2/3, What would be this distance here, guys? Exactly. You realize even though they didn't give it to you, you have to remember these things. So in your drawing, please edit these information. If I were you in the test, before I even look at the example, I would have done this. I would have put V here. So I know these two distances is V. I would have drawn my two lines like this because that tells me these two distances are the same. And I would have taken my pencil and just highlight that this is 2/3 and this is a third. Everybody understand why? You have to make sure you understand what is being shown in the image. Okay, so let's go into the actual question now. Ooh, what's going on? Express in terms of U and V an expression for LM. Let's look for where L is and look for where M is. Look at where L is. Look at where M is. But guess what? Do we have a line for PQ? What do we need to get? So let me erase all of this first thing first, for now. I want to go from L to M. What is the smartest way to go? They're saying the smartest way to go from L to P. So that's one line. Everybody agree with that first move? So far we have U. Agree or disagree? Let's go. And then where else would you travel? You would then travel along this line here. Agree or disagree? But guess what? Do we have a line for here? This is not a vector. So guess what we're going to have to do? We're going to have to travel all the way down before we could get to this part here. So let me show you what I mean by that. Let's read through what we have here so far. The diagram showing the triangle in which OP is 3, we know that. OQ is V, and the midpoint of OR, where is OR? OR, and L is the midpoint on OP. So guess what we got to do first, guys? The same thing I was just saying just now. We cannot just jump and find LQ. We have to figure out an equation for PQ, sorry. We need to find an equation for PQ. So guess what we have to do based on what we've learned all the time? To do our triangular laws to find it. I just wanted to show you guys before we start doing it without it. Everybody understand what I'm saying? If we want to go from L to M, we must make some connections first. So let's go back to the diagram. Which way did they choose? They choose to go from, they went P, O, Q, PQ. I would have gone PQ to be honest. Okay, I guess that's what they did here. Half a PQ. Okay, so let's look at it now. Let's go. So first thing first, what we have to realize is that we cannot just jump from here and go here because this is not a vector. So guess which way we have to go? You realize we have to go the longer way. Why do we go the longer way? We go the longer way because we could go the opposite direction of this vector. We have paths that we can actually travel. So we could go down like this, boom. We could go across like this, boom. And then we need to go up. But before we do that, we must complete the triangular law to find out how do we get P and Q. Everybody with me? So let's write that down first. So I'm trying to figure out how do I write this down to make it as neat as possible. So let's just start off with what we have. LM is equal to a lot of things. So I'm just going to write out the long things first. This is how I would do it personally. LM is equal to LO plus OQ. Everybody see now? But remember, that's not where we want to end. Where we want to end. And actually, this is equal to LQ. So let's just start with LQ first. And then I would want to find QM. So LM would be equal to LQ plus QM. Agree or disagree? But what is QM? Isn't QM, I just break it down so you understand all the steps that we have to do, because once you understand the overall picture, you would understand what to do. Isn't QM half of PQ? Talk to me, talk to me, talk to me. Remember, it said it, you know, remember it said so. All I doing is mapping out the paths. First, I needed to go from L to Q. L to Q. That's easy for me because all we need to do is go the opposite way. Exactly. So instead of positive 2u, what is it going to be in return? It's going to be what? Negative 2u. But man, looking at these specifics now, I want to make sure y'all understand the path that we taking. Everybody understand the path that we take? So first part was what? The first part was from L to Q. So let's check up. Let's do it step by step. Everybody understand how we get from L to Q? Because those are actually vectors, which is what we did here. So let's write out a formula for that. Everybody talk to me. What would be the formula from L to Q? What would you write in terms of U and V? Wouldn't it be, so LQ using this would be what? Negative 2U plus V. Agree or disagree? So guess what? We have the first part unlocked. This is the first part we need. This is the first part of the answer that we need. So we're going to just leave it here for now. What is the next part that we need? We need to figure out how to get MQ. But MQ is half of PQ. Do we have PQ? No, we do not. So guess what we need to find? We need to find PQ first. And then when you find PQ, what are you going to do after you find PQ? Ain't half it. So let's do that. Following the formula, PQ is equal to what? PO plus what? OQ. What was PO? Remember, PO was what? Anybody remember they told us what PO was in the beginning? What was PO? The whole distance. 3U. Excellent. So what would be? OP was 3U. So what is PO? Negative 3U plus OP, which is what? V. Tell me if you're with me. No, this is the tricky part I want to ask guys something. This is PQ, right? Right or wrong? This is PQ, isn't it? Should I find half of PQ or should I find half of QP? Let me see if we really understand the concepts and the directions. Check it out. Or does it even matter? Do you think it matters? Guess what? Look at here. Guess what? It actually doesn't, because the distance would be the same thing. Everybody see that? So you see, guess what we have? We have the elements that we need, right or wrong? We ain't got this element here. The same thing that they have here. So half of PQ, right? So we know PM. Oh, they went the other direction. Why did they go the other direction? But we can get back the same answer anyways. So let me go. We're going to go through the process. Let's go. We got this. So let's go. We're going to find half of PQ. But everybody kind of quiet. Before I continue, everybody understand how we got these two elements here? And everybody understand why we need to do that? Okay, that's very important, okay? That's very, very important. And I'm going to tell you something. The only thing that could mess you up is when you get confused with the directions. So you have to be certain about your directions. What they did here was they went and found PM, which is the same thing we're doing, but instead of PM, we found what? Look at the formula that they're using. Which formula are we using? Are we using the same formula? No, because we went the other direction. Everybody realize that? They went and find LP and then PM. What? They found LP and then PM, which ain't bad. Which one y'all would have preferred to find? Because that's an interesting thing I want to find out. Which one you would have preferred? Because I find our way makes more sense. Like based on the concept, because to be honest, let's say you were studying, it would be a little confusing as to why they gone that direction. All right, so let's keep it moving, because I feel, look how easy we were able to generate all of this without all that drama. So let's go. So we found PQ, so we need to find the other elements that we need. We don't find LQ, which is this. We need to find QM. So the only thing though I am considering is that QM is half of PQ, but I think it's half of QM. So let me show you what I mean by that. Let me just try out something and see what we get. So this is an experimentation, okay? So follow me. Let's see what we end up with. So since this is PQ, QP right, would be the opposites of that, which would be this times this. What does that become? 3U minus V. Everybody see that? So QM would be a half of that. So a half of 3U minus V. So now we have everything we need to create our formula. And what was our formula at the beginning? Our formula was these two things that we need. We needed LQ plus QM. So LM is equal to LQ plus QM. What was LQ? Negative 2U plus V plus a half of 3U minus V. So let's work it out, guys. Remember telling us something about the fractions. So guess what we're gonna do? What is the rule about algebra? You have to group all the like terms in it. So what I'm gonna do is expand the brackets. So check this. So we're gonna end up with minus 2U plus V plus a half. Or how do you multiply a half of 3U? You just put it over 2. So you're going to say 3 over 2U minus a half V. So let me know if you understand this part here, because all I did was apply the half to these two digits here. This is where your calculator come in now. If you go try work this out by yourself, this is where you're gonna make some mistakes. So let's group all of our like terms. Let me use green for the u. So 2u plus 3 over 2u. Let's use red for the v. So plus v minus a half of v. Everybody see that? Talk to me, talk to me. So let's go in your calculators. I want you to put in, y'all know how to put in the fraction part, you know, to add these in your calculator. So put -2 plus 3 over 2. Tell me where you get. I wish my calculator was working. Some people have this in the calculator, X over Y. They have a button like that, or you have a button that look like this. There's a fraction button on your calculator. I need everybody to use it, please. Tell me what you get. Okay, Jerome, that's correct. But what everybody else got that? Talk to me, because I need to make sure y'all know how to use this in your calculators. Did everybody get -1/2? Yeah, excellent. So what you're gonna realize, we get -1/2 u plus, if you have a whole v and you subtract a half of a v, even without your calculator, we're gonna be left back. If you have a whole v minus a half of v, what you end up with? A half of v in it. Everybody see that? So guess what, guys? Guess what? Whenever you see something like this, what must you do? You must factor out the thing that's common. What's common here? A half is common, so you put it out. What you're gonna be left back with? Minus u plus v. And what is another way of writing the same thing? A half of v minus u. Let's see if that's the correct answer. Guys, look at that. Same answer, different direction. This is the hardest version of the question that could come. So for this very moment, your main focus should be making sure you understand how we got here. Everybody with me? Because you realize this part is just algebra. Yeah, I realized this part was just algebra. What was the most important part? Wasn't the most important part figuring out the root, the pathway? You realize that was the hardest part? Making sure you find your pathway, you follow your pathway. So we knew we wanted to go from L to M. So I decided to follow the vectors because they're easier. This done got a letter, this done got a letter. So we just needed to find this and half it and then add all three. Because remember, this is one part, this is another part, and this is another part. How y'all feeling? How y'all feeling? So basically, we just follow the path, and that's how we get our first leg. This was our first leg. And then what we had to do was just work out this leg here. So if you are able to follow when another question like this come up, you should be okay. So for the first time, I think the fact that y'all even understand anything is pretty impressive, because I thought I would have had to, like, everybody would be like, Miss V, no, we don't understand nothing. So the fact that y'all were able to follow at least and even pick a preference in the approach says a lot. So that's basically it for that. Like I said, this is the hardest aspect of the vectors question that could come. And the next year has one just like this, and we're going to go through it. And hopefully it should be a lot more easier to follow. Okay, so let's wrap it up. This is the last question. Hey, big facts. You know, all of us aim for in life is to have tuggy students who are not afraid to handle challenges. So big up yourself one time. One time, big up yourself. All right, so let's look to the last question for this year. It says to prove that these 3 points are collinear. And guess what? It's the same concept as proving that all of them are parallel. So if you got 3 points, right? So let me just explain the concept raw. If this thing will let me draw a point. If I have 3 points, what would suggest that they're collinear? Collinear means that all of them share the same line. If I were to connect them, they would form one straight line. Everybody understand that? Confirm if you understand. That's what it says. That's what it means. So guess what your approach is. If this is L, if this is M, and this is R, guess what you have to do? From L to M is one line. From M to R is another line. All you need to prove is that LM is parallel to MR, and that would suggest that all 3 points are collinear. Remember, we spoke about that? So it's the same thing like proving the lines them are parallel is the same method you use to prove that they're collinear. Okay? So guess what they do? Look at it here. Look at it here. Look at it here. So let's go. Is this in relation to anything over here? Yes, it is. Look at here. Which 3 points they tell us? They say L what? L and who? So that was just a random example. Let's be more specific to the questions because they ask for specific points. What are the specific points they want us to prove? L, M, and R. So let's go back to the picture. Always go back to the diagram. L, M, and R. So I'm just going to show you using a demonstrative line. L, M, and R. Everybody realize? So you know, it's not even a point to say if it is. If you take your ruler and you connect them, you realize they are on the same line. You already know that they were collinear. Agree or disagree? So which 2 lines you need to prove parallel, guys? What are the 2 lines you need to prove parallel? Remember, we spoke about it. There are 2 lines, well, there are 3 actually. The 3 lines here is the biggest line, LR, and the 2 smaller lines, LM and MR. Everybody realize that, right? So you got this big line, that's 1. You have this smaller one, 2. You have this next one, 3. So if I want to prove that those 3 points are collinear, which 2 lines I have to prove are parallel? LM, I must prove that LM is what? Parallel to what? MR. But guess what? We just found out what LM is. That's what we calculated just now. You realize? So who we need to find, because we do not have MR. So this is the overall strategy. The overall strategy is to get the information for LM, get the information for MR, and see if one is a multiple of the other. Everybody with me? When you realize that, you're going to realize what you have and what you don't have. And what you would realize is that we just calculated LM. So you just need to focus on finding MR. So let's take a look at what we need to do. So you realize here we had LM because that's what we calculated before. Remember LM? And you could choose any one you prefer. I prefer this one because it's a lot more easier to manage. Everybody see that? Hi guys, are you with me? Are you with me? All right, so we just need to find LR and look at it here now. Just like how we always find any missing line that we don't have, we use the triangular rule. To go from L to R, it makes sense to go where? From L to O and then O to R. Let's go back to the picture so you can make sure you understand what we're talking about. If you want to go from, oh no, I didn't do a good job at erasing. If you want to go from L to R, what's the first place you got to go? You got to go from L to O and then from O to R. Everybody see that? You have to travel it. So that means, do we need to go through any other drama? What's the formula for LR then? It would be LR is equal to LO plus OR. What is LO? LOA, negative 2U. Talk to me. Plus OR. What is OR? We already figured out what OR was. What was OR? Excellent. You see why it's important to figure these things out even before you get a question? Because when you get to the question, you would know, you would remember, oh yeah, I could do this easy. Plus 2V. Let me ask you a question. Should I leave it like this? What do I say whenever there's a common entity on both sides? What do you do with it? You factor it out. So if I factor out 2, what am I going to be left back with? Minus U plus V, which is the same thing as well. 2V minus U. This ain't a multiple of what we had before. This ain't the exact multiple of what we had before. Agree or disagree? See how easy it is? Once you find the two expressions, you just prove that one is a multiple of the other. Look at what they did here. So they say LR is 4LM, because if one is a half and one is 2, how do you get from a half to 2? You have to multiply by what? 4. So K is equal to 4. Hence, they are collinear. Everybody seen the patterns, how these questions just come the same way, but just in different ways? And look at here, say, LR is scalar multiple of LM. This proves that LR is parallel, hence they are collinear. And literally, that's it. How are we feeling about it now? A little better? Because we're going to do one more year. We're going to do one more year, and that's it. I'm going to send you guys one question to practice, which everybody has to do. We need to be getting more contact practice with questions on your own by yourself. Because what's the point? You can't just be watching videos alone without practicing. Okay, so let's try one more year. What year is this? June 2021. I think this was a rough year, but let's see if we could handle it. So let's go. Let me know if you are ready. Before we begin, just a general question for feedback purposes. Are you guys feeling a little bit more, because this is the first time we've been looking at actual past papers for matrices and vectors. Are you guys picking up the patterns of the questions and the skills that you need and feeling like you are benefiting from this session? It's very important. Okay. Excellent. All right, so let's jump into this question. Excellent. Now let's look at this first question. Anytime you see this, you know you should never get these questions here wrong. Now, before we continue, they say calculate the product. We know product means to multiply. So we need to identify that these two can be multiplied. What's the order of the first one? A 2 by 2. What's the order of the second one? Somebody, anybody? What is the order of the second matrix? 2 by 3. Excellent. So this is what I love, because this giving us an idea of how, tricky this could get. Because this is where students just make mistakes. So let's look at this. My first question is, can these two be multiplied? Yes, yes. Okay. Because this is the last question we're doing for the night, I would like to give you guys a personal challenge to get this done on your own. But before you do so, I want you to tell me what is the answer or the order of the answer. After you multiply these two, what type of matrix you're going to end up with? Excellent, excellent. So guess what? This is a time challenge question. I want you to attempt to multiply these two, see how far you get. I'm going to get some water. When I come back, I'm going to start it. So see how far you could get on your own before I get back, please. Okay, once you guys are finished, just say done. I just need at least one person to say that they're done so that I could begin. So as soon as you finish, just drop your done message. Okay. So we have someone who is finished. I hope you guys are getting through. So I'm just gonna start setting up myself for my working. So by the time I'm ready to start, hopefully somebody else is finished. So one of the things I know is my answer is going to be a 2x3, right? So I'm going to set up a 2x3 space. 2x3 means 2 rows, but 3 columns. This does help me personally to stay focused on what I need to stay focused on. Second thing I'm going to do is identify my rows and my columns. So my rows, columns. So we have a left, a middle, and a right. So that's the connection we're looking at. Okay, so I'm going to start. If you're working, keep working. Please try to get to an answer so that at least we could get to an answer together. So I'm going to do the entire first row. So I'm going to do top, left, top, middle, top, right. So ready. This would then become 5 times 2 plus 4 times 0. This is going to be 5 times 1 plus 4 times 3. This is going to become 5 times -4 plus 4 times 6. Bottom left, -3 times 2 plus -2 times 0. I already back checking to make sure my numbers are in the right pattern. So we go again, -3 times 1 plus -2 times 3. Gone again, -3 times -4 times -2 times 6. So just back checking, looks like I'm right. So now it's time to simplify and break down. So what should I have here? I should have 10 plus 0, right? I should have -6 plus 0, 5 plus 12, minus 3 plus minus 6 minus 20 plus 24. This is supposed to be a plus here. So this would be 12 plus negative 12. So it's supposed to be 10, 17, 4, negative 6, negative 9, 0. Let's go. Out of 10, how did you manage? If I was to grade this out of 3 marks. So 1 mark, 2 marks, 3 marks. Send me how far you got. So if you know you're not 100% strong, this is a type of question you would want to get and you don't want to mess it up. So please make sure you see where you're making mistakes and work on strengthening those skills, okay? If a question come like that, you should just say, thank you, Jesus. Easy peasy, lemon squeezy. All right. Love this next question. State why the two matrices in A1 are comfortable for multiplication. This is what we just talk about all the time. What is the condition? What is the rule that allows you to multiply two matrices? The column, remember, the column in the first one times the row in the second one. They got to be matching. So that's all you have to say. Column A, the number of columns in A is equal to the number of rows in B, which is the condition necessary for matrix multiplication. Just like that, you get extra free mark. So you see, you have to be certain about everything because they can ask you questions just like this. Okay, next one. Love this question. I'm gonna give y'all a minute to do this one too. Determine the inverse of this question here. Let's go get your books out. I'm giving you a 1 minute head start before I begin. If questions like this come, count yourself very lucky. Easy marks, easy marks to make. This is simple, direct questions that you don't got to bust up your head and try to figure out what they're asking you for. It's direct questions they're asking you for. Multiply these two things. Find the inverse of this. So far, I haven't seen any question that asks us to solve simultaneous equation using the matrix form. So I think if it isn't in this question, I'm going to skip forward because we need to practice one of those. Those come a lot. Okay, so we have some people who are done. So if let's call this P. So P inverse would be equal to the formula we spoke about, the determinant of P times the adjoint of P. So what is the determinant? So determinant of P is equal to 5 times negative 2 minus 3 times negative 3, 4 times negative 3. Agreed? So this would be what? Negative 10 minus negative 12. So your answer is what, 2? So your answer is 2. The determinant is 2. The adjoint, simple process for the adjoint. What do you do? Switch the two numbers. So the adjoint is negative 2 here, 5 down here, negative 4, positive 3. So it's just for us to apply. So the inverse is equal to 1 over 2 times all of this. So you know what you got to do next. You apply the half to each. So I'm just going to come across to do that and simplify below. So this is going to become negative 2 over 2, negative 4 over 2, 3 over 2, 5 over 2. So your answer should be negative 1, negative 2, 3 over 2, 5 over 2. Yep. How much people were able to get somewhere with this? You realize it's the same concept happening over and over. Inverse is the easiest thing to find. You always just remember the formula. Okay, that's a question. Janella, that's a hand for a question, or that's just you agreeing?
No, that is me agreeing. It's just that I take a little longer than I usually does.
Okay. Okay, no problem. So once you're able to do it though, you could always practice your time, but you always want to try to make sure you understand the steps you need to take. Okay. Let's get into our vectors. This one looking a bit roughy, but I think we can do it. Remember, I told you this is how these questions just come all the time. Check this out now. We got a triangle OAB. The first thing I just look for is what vectors they gave us. They gave us two vectors so far, OR, or OC, which is R, and OB, which is S. So now it's to figure out the other stuff. So OA is R, they have that already. OB is S, you have that already. In addition, E is the midpoint of CD. E is the midpoint. So, you know, this and these two lines are equal. You see the same thing again? Instead of a third, look at what they gave us now. OC is equal to 3/4 of OA. Where's OC? So this is 3/4. So that means this one is what? 1/4. Everybody see that? Similarly, they said AD is 2/3. So here to here is 2/3. That means from here to here is what? 1/3. So it's the same concept like before. So let's try burn through this quickly and follow me. So you don't have to write, just follow me and make sure you understand what we're doing. So give me an idea that you guys are ready. You don't know what you should be expecting. You don't know we're going to have to deal with fractions. We're going to have to deal with finding missing lines that we were not given. We're going to have to do a lot of work to get what we need. So we're mentally ready to do that. This is just our challenge question. So let's go. They want us to find, express in terms, you realize in terms of R and S, this in the simplest form, an expression for CD. So let's look at where CD is. CD, that's what we're looking for. This one is way more complicated. Why is this more complicated, guys? Anybody realize what's going on here with CD? There is an E. For me, what I would choose, let's go the shortest path. Let's go the shortest path here. They only give us the midpoint. And guess what? We don't need the midpoint. This question is actually pretty even harder than the one before, to be honest with you. Because guess what? To find CD, let's do a path. Let's do the path. Let's do the path. Let's do the path. Let's say we're starting from O. Remember, we always find your path. So don't even worry about the letters yet. Just find one way to get from one point to CD, okay? So I want to get to CD, or I want CD. I could go from O to C. Everybody see that? But is there a direct line from C to D? This is not a vector. So I can't just follow that just so. I can't just cut cross here just so, because it's not a vector. Everybody see what's going on? This is very stressful, actually. Yeah. I find this really stressful. So how do we do this? To get to D, we must find AB. Everybody agree with that? You can't get a fraction of the line if you don't have the whole line. Agree or disagree? So there are some things we need to find, which include finding the formula for AB. So did they give us anything for OA? Oh, yes, they did. Oh my God, guys. I realized what happened there just now. Do you know that R is not from O to C? Where is R? R is the entire OA line. Okay, now I understand, because I was like, this is why I thought it was hard. Okay, ain't so hard no more. This entire line is R. No problem, Lovey. See you. Okay, we good to go. So let's go. How do we find the formula for AB? So that's the first thing we need to do. We need to figure out the formula from AB, and then we need to find out the formula from OC. So let's get our big lines first. What is AB equal to? Anybody could tell me what AB is equal to? AB is equal to AO plus OB. Agree or disagree? And luckily for us, once we find AB, we can find AD, because look at it here. AD, look at it, the formula there. So we just writing down everything we need. So from that, AD is equal to 2/3 of AB. That's the first step. So step one, find AB. Step two, find AD by finding what? 2/3 of AB. Let me know if you're following me. You see what path we're taking so far though? Excellent, excellent. So we so far are here. What other line we need, guys? Let me see if y'all could tell me without me saying, what line do I need next? So I have this part to get to D. But what do I need to get from C to D? Don't I need CA? Talk to me, talk to me, talk to me. So how do I get CA using the triangular law? What information would allow me to get CA? I don't even know why my thing slanted like that. CA, sorry. CA, look at the formula up here. We know what OC is, and we don't know what CA is. What's CA, guys? If OC is 3/4, exactly. Oh my God, guys. Everybody see that? Even though that's not what this is an indirect understanding. So that's why it was important for us to identify that earlier, because we know that AC or CA is simply just a quarter of what? OA. Talk to me, talk to me, talk to me. So are we ready to find the elements? So guess what then? CD would be equal to what then? CA plus AD. So whatever answer we get from here and whatever answer we get from here, we add them up. Agree or disagree? Let me know if it seems a lot easier now. If you're following it a lot easier now. Everybody following it a lot easier now? So all we got to do is substitute. So for example, what is our value for AD? We don't know that AB, you have to add these two things. So let's go. What is AO? AO was what? Let me use black. What letter represents AO? Look it up here. AO. But is it positive R or negative R, guys? You see, that's the part. Look at it. Would it be positive R or negative R? You see that? You got to pay attention to the direction. Excellent. So it's going to be minus R plus what? Plus what? What is OB? Excellent. So this is the formula for AB. So AD is just 2/3 of that. And instead of having it as, let me just put it like that for now, minus R plus S. So you see, we got the first part already. So I'm just going to substitute it in. So that's just plus 2/3 of minus R plus S. Now let's find the CA part. How do we find CA? A quarter of OA. What is OA? OA is just what? OA is just R. Isn't that correct? So it's just going to be a quarter of R. And what is the thing we realize? We got to deal with the fraction part now, right? So let's break it down. We don't have to trouble this because it's straightforward. So we just need to expand the brackets. So when I expand the brackets, I am going to end up with, to be honest with you, this is going to become minus 2/3 R. Everybody see how it's going to become minus? Because a positive times a negative is a negative. Everybody see that? Plus 2/3 times S, which is just 2/3 S. So confirm with me if you're following so far. So let's get the calculators out. Let's get the calculators out. A quarter minus a third. Calculator people, let's go. A quarter minus a third, 2/3. Positive or negative? Excellent. So negative 5/12 plus 2/3 S. R plus S. Guys, guess what we did? We did it. So how everybody feel? You realize we generated the general formula and then we found the elements that we needed and we just substituted and we simplified. That's it. You follow the path. You create the path, you substitute it, and you simplify. Everybody see that? So confirm if you got it, if you understand how we got it. Like I said, this is the hardest part of any vectors question. Once you understand this, you're going to be good to go, promise you. Okay, so let's move on to the next part. Now they want us to find OE, Jesus is the last one, and then they just want to plot the points, which is easy because once you know these things, it's easy. So let's go. They want us to find OE. Where is E? Oh, so they want us to find OE. What is a pathway to get to OE, guys? Based on what we learn. How do I get from O to E going the long way? Wouldn't it be this? Let me use yellow. Wouldn't it be OC plus CE? And so based on what we know, what is OC? OC is what? 3/4 of R plus, and we know that CE is what? CE is half of CD, and we just find CD. So we just need to do what? Find half of this. You see where the drama is coming in? Oh, look at it right here. So let me zoom in. Exactly what I just say. 3/4, this part represents OC, and CE is a half of what we just found just now. You realize the drama here? So what would we do? We would multiply out these values. So this is why I was telling y'all it comes down to the fractions. So you put in your calculator, you don't even need to, because 1 times 5 is 5, 2 times 12 is 24, and you put back the R. Same thing here. If you want to expand this, 1 times 2, 1 times 2 is 2. 2 times 3 is 6, and you know 2 over 6 is the same thing as 1 over 3. So all they did was simplify to its lowest fraction, for those who may not understand where the 1 over 3 came from. Everybody following so far? And then just like what we did before, you add the 2 R's or you subtract the 2 R's. That's what it did with this term here. And they end up with 1 R value, and they brought back down the S value. So you realize it's not hard. You find the pathway, you look for the formula, you find the values, you substitute, and you simplify. So that is it. And the last question is, the points O, P, Q have coordinates respectively. Write OR as a column vector. That's so easy, guys. What is OR as a column vector? We just did that earlier. What's the value of OR? Everybody, what's the first value in my OR? OR is going to look like this. X to the top, Y to the bottom. So what's the X value to the top? Look at where the X value is. If this is the R, what X value corresponds with that position? So it holds a -1 position. What Y position does it hold? A +4 position. So that's it. That's the answer. So guess what? We are done with vectors. So we only did how much exams? 3 exams for tonight. So oh, we're not done. I got one more question. I think it's the magnitude, and we did magnitude already for the night using the formula. So let me just zoom in quickly. Give me 1 minute. So yeah, we did this already. If they want the value of QR, you just get the points for QR, and you find blah, 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 you find, yep. See, first of all, you gotta find QR, because Q, you know, Q just means OQ. So you use OQ to find QR. Once you find QR, you plug it in the formula and you find your answer. So that's it for tonight, my awesome people. How do you feel now? And the truth is, we didn't finish one question I wanted us to try. Let me see. But I'm going to send it to you guys still, which is the one with solving the simultaneous equations using matrices. But small thing. Out of 10, how do you guys feel about what we did tonight with matrices? I'm watching. Okay, so tonight I'm sending everybody a mock exam 3, and it's only 3 questions. 1 on matrices and vectors, 1 on investigation with the patterns, and 1 on statistics. All 3 very straightforward questions. You guys have until next week, Sunday, to send it to me. So I need y'all to work on that specifically. My class, you have until Friday to get it done. Private students, you have until Sunday to get it done. Okay? Awesome, no problem. So that's it for tonight, guys. Thank you guys for coming. I'm going to post up the recording for anyone who needs to look at it again, but have a great evening.